So we're going to take a few quick notes on properties of exponents, sort of a quick intro to chapter 3 that we'll be dealing with after the financial math unit. So there's the first one, a to the m times a to the n equals a to the m plus n. So get that one written down, then just pause the video right now and have a quick discussion in your group about why that's true, and maybe have a numerical example or two to support your reasoning. So pause the video and have that quick discussion. Okay, welcome back. It's good to have these memorized, but it's also good to understand why they work. So if you just do a simple example like 2 to the 4th times 2 to the 3rd, of course 2 to the 4th means 2 times itself 4 times, right? And then 2 to the 3rd means 2 times itself 3 times. And so all together we have how many 2's? Well, we have 4 plus 3, which is 7 2's, right? And so that's why we're adding that exponent in that situation. Here's the next one. We often call this one the power to the power rule. So a to the m, all raised to the n, equals a to the m times n. And so if you just do the sort of companion piece here, 2 to the 4th cubed means 2 to the 4th times itself 3 times. And then we just use the property that we had before. Here we have 4 2's, 4, 4, and so all together we have 12 2's. And so the fast way to do that is to just multiply those exponents. So that's property 2. Property 3 is sort of the mirror image of property 2, and so, of property 1. And so here in property 1 we were multiplying with the same base. Here we're dividing with the same base, and in this case we subtract the exponents. So a to the m over a to the n is a to the m minus n. A to the 0, if you apply this property, you can sort of derive this one. A to the 0 is always 1. And again, you can sort of see that by, let's flip this around. If you do a to the 5th over a to the 5th, of course, that's a giant 1. We know that's 1. If we apply the rule of exponents from number 3 and subtract, we get 5 minus 5. So we get a to the 0. Notice that it doesn't work when the base is 0. 0 to the 0 is undefined. You'll talk more about that in calculus at some point. Number 5, roots turning into exponents. So if you take the nth root of something, that's a rational exponent, and the n tells you the denominator. And so if you see something like 8 to the 1/3, that means take the cube root of 8, which of course is 2. Okay, so we're halfway done. So nth root is a rational exponent. And number 6 is what happens when you have an exponent inside the root, and so that m just goes on the top. And the sort of key thing with this one is that you can sort of switch the order around if you want or need to. So over on the left, we had taken the mth power and then did the nth root. We can do it in the other order. So we can take the nth root first and then do the nth power after that. And that's especially handy if you need to do a problem without your calculator. And you will need to do some like this when we get to the assessments for this unit. And so, for example, if I want to do 8 to the 2/3, right? There are 2 ways you can do it. One way is probably a little easier than the other. And so I'm going to do the cube root first and then square the answer. So we had just done the cube root of 8. We got 2. And now I'm going to square 2 and get 4. Okay? So that way is a little easier to do in your head. You technically can do it the other way. You can square the 8 and then take the cube root. Right? And so I'm going to have to take the cube root of 64. That one is 4, and you could probably do that in your head. But it's a little easier, I think, to do the cube root first in your head. Then we get into negative exponents. Negative exponents take the reciprocal of the base. And so a to the negative n is 1 over a to the n. And so it's not written out real nicely there. It's a fraction with a to the n in the denominator. Number 8 is basically applying this to a fraction. And so if you have a fraction to a negative power, it flips the whole fraction over. So the b was in the denominator, now it's in the numerator. A was in the numerator, now in the denominator. They're both to the n power. This one is sort of the distributed property for powers. You can sort of think of it as when you have a, b all raised to the m, both of those get raised to the m power. And then same thing with fractions. If you have a fraction raised to the m power, both the numerator and the denominator get raised to the m power. So you're going to work on some practice problems using these. I'm just going to show you one sort of example that you can expect to see. So if we have a to the third, b to the second to the negative fourth, and then a, b cubed to the third, first thing we would do is sort of do the power to the power. And so a to the third to the negative fourth would be a to the negative 12th. Then I get b to the negative 8th. And then here, this of course is like a to the first. And so I'm going to get a to the third and b to the 9th. And so now I'm going to use the adding property. So a to the negative 12th times a to the third is a to the negative 9th. B to the negative 8th times b to the 9th, I add, I get b to the first. And this is fine. Oftentimes we don't want to leave negative exponents, and so we'll use that reciprocal property and move that a to the 9th down to the denominator. So sorry, my a's and 9's are looking messy there. So that's a to the 9th in the denominator. All right, good luck on the practice.